All right, let's go ahead and get started. Today, we're jumping into the second third of our course, picking up where we left off. So we started the midterm. We had gotten halfway through chapter 6. We looked at the graphs of all 6 trig functions, and we practiced going from the equation to the graph. Now we're going to talk about how to go from the graph to the equation. And then on Friday, we'll introduce the inverse trig functions, and we'll talk a little bit about what the graphs of the inverse trig functions look like and what we use them for. Yeah? So let's start with this example. We have a graph. Yeah? And the first thing I want to do to write an equation is probably identify which of the 6 trig functions is the best match. Yeah. So first step is match graph to a trig function. Ooh, that was messy. So looking at the graph here, of our 6 trig functions, sine, cosine, secant, cosecant, and tangent, cotangent, which one do we think best matches that guy? And I'll give you just a couple seconds to think, maybe discuss with your neighbors, and then I'll need some volunteers. Okay, we'll start with Nick's table. Nick, what does your table decide? What do you think? Give me a vote. What do you think? Tan? We've got to vote for tan. We've got 1 vote for tangent. Liv, what does your table think? We've got 2 votes for tan. Very good. Emma and LD, what do we think? 3 votes for tan. Desi, what does your table think? Tan. Is there anybody in the room who thinks something other than tangent? No, we all think tangent. Okay, why do we think tangent? Why is this a tangent function? Yes, Valeria. Arely, I know who you are. I'm sorry.
I think it's because it's that S shape, but it's the part on the positive side that's going up.
Good. So this is an S shape, which narrows it down to tan or cotan, and it's increasing. Very good. So those are the 2 things I look for tangent. S shape and it's increasing. Cotan would be decreasing. Yeah, very good. I think that's a great choice. The next thing I'm going to do is write the equation out, yeah? So for tangent, y equals a tan bx minus c plus d. That's a shifted tangent function. Tan x is the parent. A tan bx minus c plus d is the shifted. Yeah? And our goal is to find those 4 variables, those 4, well, constants that we don't know, unknown constants, from the graph. What's my A, what's my B, what's my C, what's my D? We are not going to do them in an order that makes sense. We're actually going to do them out of order. We're going to do D first, and then jump to B, and then come back to C, and then do A. And there is a reason for this. It has to do with the ease of which we can pick these off the graph. So next step is to find D, which we know is where the midline is. So for an S curve, I'm looking for the point where it goes from the slope is decreasing to where the slope is increasing again. So where do we think the midpoint of our S's are? 0, yeah. That looks like the midline to me. And that's the equation y equals 0. So I think that my d is likely 0. This tangent hasn't been shifted up or down. No. That's not so bad. If it's a U shape, if it's a secant or cosecant, we're looking for the line that's halfway between the bottom of the up U's and the top of the down U's. If it's the sine cosine, we're looking at the line halfway between the peaks and the valleys. Yeah? Good. Next one, we're going to find B. And B is equal to the old period, the period of the parent function, over the period in the graph. And we're writing it that way because we have 6 trig functions and not all of them have the same period of their parent function. 4 of them have an old period of 2 pi. 2 of them have a period of pi. We have to take that into account. So let's scooch you up. We'll do that for this guy. It's going to be a fraction. For the top, I need the period of the parent function for tangent. So what is tangent's original period? Pi. Tan and cotan are pi. Good. So top is pi. And then I'm going to go to the graph and figure out what the width for one full cycle is. And for tangent, that's from asymptote to asymptote. Because one single s is a complete cycle of the tangent. So this right here is the period in the graph. And how far apart are those asymptotes? -4 to +4, how far apart are they? 8, yeah. Yeah, this equals 8. So this is pi over 8. That's perfect. Yay. Halfway done, got 2 of the letters. Next one is to find C. Whoops. And C is equal to your phase shift times B. That comes from the definition of phase shift. Phase shift is C over B. I'm just solving it for C. We know what B is. It's pi over 8. Yeah? Now I need to figure out what my phase shift is. So I know C is going to be something times pi over 8. And we're going to pick an easily identifiable point on that curve. If it were sine, I know sine starts with a 0 on the y-axis. I would look at where that 0 is actually sitting. Tangent, a lot like sine, starts with its 0 on the y-axis. This graph also has its 0 on the y-axis. If that intercept is in the right spot, we haven't shifted side to side. That tells me that my phase shift is 0. I haven't shifted the curve front or back. So this would be 0 times pi over 8, which is just 0. There's no phase shift. He's sitting where he should be. He's just wider than he should be. 3 out of the 4 numbers. Yay. The last one, we have to do a little bit of work for it. And that's the vertical stretch. That's the A. It's easy to see whether he's been stretched sideways, because I can just look where the asymptotes are. The vertical stretch is harder. So to find the vertical stretch, yeah, we are going to pick a point on the curve to solve for A. going to have to do some algebra. A note about this point, you should not use the origin. Do not use 0, 0. So I put a 0 on one side and a 0 on the other side. I already know 0 equals 0. That's not helpful to me. So you cannot use the origin as the point. Any other point on the graph works. I recommend positive numbers and points that are easy to identify. So if I go to that curve, I see that if I'm at 2 on the x-axis and I go up, that puts me at 2 on the y. So the point 2, 2 is on my graph. That's what I'm going to use to solve for A. Yeah? Okay, I'm going to scoot sideways here. I'm going to ask you to bear with me. We're going to do some math. So I'm going to come up here, and I'm going to come back to this equation, the one we started with. And I'm going to take that point we just chose, right? X is 2, y is 2. And I'm going to take the 3 values I found, D, B, and C, and sub all of those numbers into the equation so that A is the only thing left. So instead of y, I know y is 2 is A times tangent. I know B is pi over 8. I know X is 2. C is 0. D is 0. So all I did is I took the 3 values we just found and the point from the curve and substituted them in here. Yeah? Now it's an algebra question. My calculator can figure out what that tangent function is. It's going to give me a number. I just got to solve for A. So we're going to simplify. We're going to get this thing by itself. It already is. We're going to figure out what the tangent is, divide it out. Yeah? I'm going to do some simplification first, because I know that pi over 8 times 2 is just pi over 4. The 2 on top and the 8 on bottom become a 1 and a 4. Pi over 4. I'm going to grab my calculator, and I'm going to look at what tan of pi over 4 is. What setting should your calculator be on? Radians, very good. If we're working with pi's, we're in radians. Very good. So tan pi over 4. Show me on your hand what you get. I see a bunch of people doing this, which is correct. Tan of pi over 4 is 1. If I divide both sides by 1, 2 divided by 1 is just 2. A must be 2. There's a vertical stretch of 2. That point is twice as high as it should be. That's it. Now we just substitute everything in. I go back. Y equals, I now know my A is 2. Tan, my B is pi over 8 times X. I have no C, I have no D. It is those same steps every time. There's no variation. Doesn't matter which trig function's on the graph. You're finding the things in the same order. You're doing the same things to find that A. Yeah? Every time. We're going to do 2 more together, and then I'm going to have you do 1 or 2 on your own in your small groups. Yeah? So before we do the next one, questions on the process? Questions on where any of those numbers came from? Glad to see you're all alert and awake. Okay, let's go ahead and do another example. This one was big and messy, because that was our first one. Now I'm going to show you what it looks like when you're just scribbling on your graph. It doesn't have to be this complicated. Yeah. So first example, we're looking at this graph over here on the left. And the first question, what trig function does it look like? Take a minute in your small groups, discuss. I'm going to call on this half of the room because that half of the room started the last one. What trig function does A look like? All right, Alfredo, what do you think that one looks like? Gotta vote for cosecant. Did anybody else decide cosecant? I see some nodding, some thumbs up. Very good. All right, up here, I'm going to make a note. This is a cosecant. Why cosecant and not secant? Very good. You could use secant here, and you'd still get the right answer. The buddies still work. You can use sine or cosine for a wave. You can use tan or cotan for an S-curve, right? You can use secant or cosecant for the u's. But choosing the right one will make those other numbers that you're solving for prettier. So I agree, cosecant's the right choice because this guy doesn't have a y-intercept. Yeah. Okay, so next thing, I know I'm looking for 4 letters. First one is D. Where is my midline? So looking at the graph, this guy's bottom looks like he's at 1. This guy's top looks like he's at -1. What is halfway between them? 0. Perfect. My midline is here, which tells me D is 0. Perfect. Quarter of the way done. Next one, we do B, right? B is original period of the parent function divided by period in the graph. So B equals fraction. The original period for cosecant, 2 pi. Very good. 2 pi. And then I go to the graph, and for secant and cosecant, a full cycle is 1 up u plus 1 down u. Meaning starting here at the beginning of the up u and going all the way to the end of the down u. That's a full cycle, up and down. And I need to know how far apart those are. Pi, yeah. 0 to pi is pi. So I'm dividing by pi. And 2 pi divided by pi is 2. B is 2. Perfect. Halfway done. Next is my phase shift, which tells me C. Phase shift times B is C. And I'm looking for a recognizable feature, either a 0 or an asymptote. I know that the cosecant parent graph has an asymptote on the axis and then goes up and then down. This graph has an asymptote on the axis, goes up and then goes down. So this graph has not been shifted sideways. He's centered where he should be. That tells me there's no phase shift. That tells me C is 0. 9 times out of 10, I'm going to give you graphs where C is 0. If C is not 0, it's going to be really obvious it's not 0, and it's going to be easy to find because I am a nice person. Perfect. And then the last one, the one we got to do some algebra for. Yeah? We're going to find A. I need a point on the graph. I'm going to choose the bottom of that U. I know the X is pi over 4. It's nice and labeled. And the Y is 1. Pi over 4, comma 1. So I'm using pi over 4, comma 1. I'm starting with the equation y equals a cosecant bx minus c plus d, and I'm plugging the numbers in. Yeah? So what am I plugging in for y? 1. Perfect. y is 1. A is the thing we don't know, times cosecant. Our b is 2, and our x is pi over 4. C and d are both 0. Make it a little prettier. 1 equals a cosecant. 2 times pi over 4 is just pi over 2. 2/4 make a half. And that's something I can plug in my calculator. Cosecant does not have a button on your calculator. So when I go to evaluate this on my calculator, I'm going to do 1 divided, and what's the buddy of cosecant? 1 over sine. Yeah, this is going to be 1 divided by sine of pi over 2. So 1 divides sine pi over 2. And show me on your figures what you get. I see a couple ones. Yeah. So this is just 1 equals a times 1, which means a is 1. Yeah? Let me write it out. Y equals, if a is 1, do I really need to write the 1 out in front? No, because anything times 1 is itself. Cosecant of 2x. A is 1, b is 2, c is 0, d is 0. Yeah. Notice that the first 3 of those happened on the graph itself. I didn't have to write out a step list. I didn't have to make it complicated, right? D, B, C, you can do on the graph itself. It's only A as a last step where you really need to show some algebra. Yeah? Questions before we do another one? No. Okay, I'm going to have you guys help me with this one. Scoot you down. Bless you. Okay. Last graph. We got B. First question, what does that look like? What function does that look like? I've got to vote for cotan. Why cotan? Why is it cotan? I agree. I'm going to write it on the board. I'm that confident. Why cotan? Very good. It doesn't have y-intercept. It's that S shape. Yeah, it's making the S shape. It's decreasing instead of increasing. And it doesn't cross the y. Perfect. That's exactly right. This looks like a classic cotan, but it doesn't look like it has the same period because look at what we're counting by on the axis. So it's probably been stretched horizontally. Yeah. But we're going to find these things in order. We start with D. D is our midline. Where's our midline? 0. Not all of them will be, but this one is because I can see where it's crossing. That's the middle of the S. So D is 0. Perfect. What do I look for next? The period. I need to find. Why? Oh. While we're waiting, since you said it's cotan, what's the period of cotan? Pi. Perfect. So we need to figure out what the period on the graph is. would be pi divided by whatever that is. Yay, didn't even delete stuff. Shoot. So pi divided, and then we go to the graph. One cycle is a full S, which is asymptote to asymptote. What is the width of that S curve? 1. Yeah. It's pi over 1, which is just pi. Perfect. Next, we look for C, which is phase shift times B. And the phase shift has to do with how we've shifted it side to side. And we chose cotangent because the asymptote is in the right spot. There's an asymptote on the Y and then a decreasing S immediately after, which is what cotangent should do. There is no phase shift here. The asymptote, that is the central asymptote, is exactly where we expect it to be. Next step. I need to find A. What do I need to do to find A? Pick a point. Very good. Anything but the origin. This graph doesn't sit on the origin. I can pick any point. Which point do you suggest? Alexis, you got a suggestion? What would you use? I see one that's already been marked up there. Yeah. Why not use 0.5 comma 0? I don't see anything wrong with that. Let's try it. What does it give us? Y equals A, not tan, cotan. And then B is pi times X is 0.5, C and D are 0. And we're going to plug in Y. Y was 0. This is equals 0. I see a problem here. Even if cotangent of 1/2 pi is not 0, that's not really going to help, yeah? Because 0 divided by a number is just going to tell me A is 0. And I know A is not 0 because I have a graph. If A is 0, I wouldn't have a graph. So this point looks tempting. It's not actually helpful. Yeah. So yes, you should avoid the origin. You should also avoid any of the other x-intercepts. Yeah. So we need a point that's not on the axis, but we can pick off. And my suggestion is the one right next to it, which is 0.25 and 1-ish. And we did that because that's tempting, right? I wanted us to see what happens. You can't use that because the A just is 0. That's not helpful. So I'm going to use 0.25 comma 1. That should give us some helpful information. So for that point, what's my Y value? 1. 1 equals A times cotangent of pi times, and my X is 0.25. Yeah. And we need to know what cotangent is. On your calculator, do you have a cotangent button? No. So this is going to be cosine of 0.25 pi over sine of 0.25 pi. And I happen to know what that is, because I know that pi over 4 sine and cosine are equal to each other. I remember the unit circle. But if you don't remember, what is that when you plug it in your calculator? Need some confirmation. Should be 1, yeah. If it wasn't, I'd be worried, because again, we know pi over 4 sine and cosine are equal. They're both root 2 over 2. Yeah, good. So A is 1. Y equals cotangent of pi x. Happy face. Reminders before I set you loose to do some practice in your small groups. If you have a d, there is a plus or minus d, you need to move that to the other side before you evaluate the cotangent and divide. Right? Because we are solving an equation for an unknown. You have to work reverse PEMDAS. Undo the addition and subtraction that's outside over here before you tackle the inside stuff. Yeah? Okay, so you've got a little bit more than 15 minutes. There are 2 questions on the back of that worksheet that ask you to do the same thing we just did together. Those solutions are going to be your warm-up. I'm going to call on 2 groups to present tomorrow for our warm-up. Yeah? If you finish both of those, try it in class. What should you get started on? Homework, week 7 homework. Very good. All right, I'm going to circle and check in with each group. We're working on the try it on the backside.